Alright, in our last video we showed you some basic game logic, and the problem is that logic is going to get really messy if we continue to just spit out all the logic in the game, because notice we only kind of have a very skeleton of what you could do in a game, and we haven't actually built in any of the logic to validate that a player's doing what they should, that they didn't make a wrong move, that they didn't put in the wrong input and we don't understand it. There's none of that going on, and this code would get really messy if we continue to just put everything in our game loop and don't actually make it nice. And this is really a real game, so we were just learning about while loops and continuing and breaking. So it's time to actually learn about functions now. So a function is something that we're definitely going to take advantage of a lot in Python, and this is really when we start using coding languages for what they're intended for doing repeated functionality over and over again with minimal effort on our end after we write it once. So we can start off with some basic functions, like understanding that if we write the, I need the Python cell here. If we write the def keyword and then we name whatever function we want in a similar way we would do a variable. So I might say print hi, and that's the kind of typical example you would see. Then maybe afterwards we would just print hi. Okay, now what I want you to notice is that we definitely said I want to print hi and nothing happened, but that's because I defined this function. Now there's a few things about this syntax, is that you need to put the def keyword and then a space and the name of the function you want, following probably your standard variable syntax there, where you have it all undercased with underscore separating. And notice now what you need is you need a set of open and close parentheses. Now stuff can go inside that parentheses, but there doesn't need to be anything in there. And then on an indented line in your function, as many things as you want. So you could say x equals 5 plus 5, and then x minus equals 7, and then print x as well. So again, if I run this, nothing's going to print, and that's because all of this code takes place inside of my print hi function. And what I've done is I've defined my print hi function, but I've never used it. To do that, I'll get a new cell and I'll say I want to print hi, and notice I need an open close parentheses. If I don't include them, let's run this and see what I get. I get that there is a function somewhere in the main file called print hi, but I actually want to use it, so I need to use the parentheses, and there we go. I get hi and I get 3 because it also did that extra math logic and figured out that x will now be 3. Okay, now here's some super important things I want you to know right off the bat before we go any further. I want you to know that although x was inside of this function and I even printed x, all right, if I call x right now, it's going to say x is not defined. So really early on, I want to introduce you to this idea we call scope. And what scope means is this: if I introduce a variable inside of a function and never bring it outside of the function, then that variable doesn't exist outside the function. So again, I defined x inside this function right here. It didn't exist before in my file. I did some stuff with x and I printed x, but printing x is a whole lot different than returning or storing x in a variable name. Now that variable name's only stored inside of the function's what we call scope. So after the function is done running, unless x is returned to us in some other way, or unless x was defined beforehand in my file before I got to this, then x will now no longer be able to be accessed. So that's a good thing and a bad thing, but it just takes a lot of time getting used to whether you've got a what we call something in the local scope of the function or in the global scope of the whole Python file. But the more you get used to it, the better you'll find why that's an advantage that they separated it out like that. Okay, so we've got basic functions that can do things like print, and that's really basic functions. Now, how can we make this take an argument? Well, we could do the stereotypical, we want to insert a name, and we want that maybe default name to be Bobby. All right. Now, That's one interesting thing, is that you can provide default names. So what we can now do is, instead of doing some logic, we could say print hi, and we learned about f strings before. So we could print hi, and then we could say name. All right. So what I can do now is I can, since I reran print hi, it's now a new function. I can just press print hi and it says hi Bobby, because if I don't provide a name, it's going to just assume that the name is Bobby. It's going to say, okay, the name's Bobby because you told me it was. But what I could instead do is I could say print hi and I could say David, and now it's going to say print David instead, because this time what I did was I provided an argument for the name. All right. Now notice that I didn't need to specify that I want the name to be equal to David, because what happens in Python is it knows there's only one, what we call parameter, being passed in. There's only one, name. So if I pass anything in here, it's going to assume that that is going to the name category. So I only made it so my function can input one thing, and whether I call it out by name or not, if I provide it with one thing, it's going to assume it knows what to use. And now we could switch this up and we could say I want to print hi Sally. And we could probably break our code pretty quick by even saying I want to print the list 0, 1, 2, 3, 1, 2, 34, I guess. And actually we didn't break it, but now name is the list 0, 1, 2, 3, 4. So cool. I guess that's one consideration for noticing that, hey, you might be able to pass more than what you think you can into your function. Just because you say it should be a name, unless you find a way to restrict it or catch that this is a list and not just a name, then it will do what it is instructed to do. Great, so we talked about basic functions and functions that take arguments, right? We can provide an argument, or we could give a standard one. If you don't give a standard argument, all right, let's just show what happens there, just to say we did. If you don't provide an initial argument, when you clearly say that there needs to be one, then now when you run this, you're going to get an error saying that you are missing one required positional argument, name. In other words, you said that this function needs a name provided, and you never gave me one. Now we could even say I want a name and I want an age, right? And I could say that my name is, once again, Bobby. And this time, I want you to notice something, that even though the age isn't being used, we're still going to get an error saying that age wasn't provided, even though age didn't actually go in this function. So if you plan to ask your user, or if your function needs a certain amount of arguments, then make sure you always give it the exact amount of arguments you define in there. So I could say that Bobby's 47. Now it will run, but we're not even doing anything with age. But however many arguments are inside your initial definition, that's how many you must provide every single time, unless we get into args and quargs, but that's for another time because it's a more complex topic. All right, so the amount of arguments that you provide must match the amount of arguments required, whether they're used in the function or not. Okay, so so far what we've been doing is we've been using a function to only print things out to the console, but that's not going to be good, because at some point we probably want to return some values. So let's say that we had x equals 10, and let's say that I want to make a function that will square or add 20. That's what I'm going to name my function, which is kind of silly. And it's going to take in a value, and it's going to take in a instruction. All right, so what I can do is I can say if the instruction is equal to, not assigning, we need double equals there. If it's equal to square, then what I can do is I can return, in fact, well, I guess we're building a more complex function, but that's fine. Maybe what I'll do is instead is we'll even just put return right here first. I want to introduce this concept a little earlier. Okay, let's go back to just this one right here. Okay, so now instead of printing, we're going to be returning. And so what's the difference with that going to be? Well, now I get hi Bobby here, but what I can do now is I could say message is equal to hi Bobby. And now what I've done is not only have I essentially gotten hi Bobby in there, but now I can call on that new message string and I can use it whenever I want. So notice that instead, if I just simply write print and I want the message to be equal to print now, that I'm going to get nothing out of this, because this function will only print something to the console, but it won't actually return anything to a variable name. We can't pass this message back to a variable. It's printed once and it's gone forever. So if we want a way to preserve or hold on to that message, we can use the return keyword. And now when you return something, you're probably going to want to be catching it, so to speak, in a new variable name. So now that I am returning hi name, then I can now catch that message inside of a new variable name, and I can then use that new hi message wherever I need to. Okay, so I just wanted to show the return before we put it in an if else block. So if the instruction is square, then what we'll return is we'll return the value squared. You can do double multiplication and then provide an exponent. Else, and we're just going to say else here. So in other words, if it's not going to square it, then we're definitely going to add 20. Now that means if I just mistype square or anything else, then I'm going to get 20 added to it. Maybe that's the behavior I want. Maybe I'm not. Maybe I don't. Maybe I want to make sure it specifically says add 20. But I'll just say else for now, just to show you, again, maybe the danger of how you format your code and why you might want to be very specific for what the requirements are for things to square or have 20 added. So else, I'm going to return value plus equals 20. We've learned about that before. Okay, now why would you want to square something or add 20? Whoops. Why does it not like that? I guess I'll just do plus 20. Okay, I don't know what that was about, but that's okay. So either we're going to square it or we're going to add 20. Great. Well, then let's see here. We'll do square or add 20 to x, and let's say that I do want to square it. And now when I run that, it's going to give me 100, and that's going to be returned. Now, once again, what I want to show you is that value right now is no longer defined, and also the word instruction is no longer defined because I did not return the word value, or I did not return the variable value outside, or I didn't catch it yet. But what I can do is I can catch it by then saying new val is equal to the result of my function x and square. So now I look at new val and I see that new val is 100. So again, if you want to catch that result of your function, then you need to attach it to a new variable. You need to say my new variable or my new value is going to be equal to the result of this function. So cool, I can grab that new value and then I get 100. And once again, just to prove the point, if I even just mistype it, then now I'm going to have 20 added to my original value of x. Now notice also what we're not doing here is that the value x being 10 is never changing. All right, so I'm providing x and we are modifying x, so to speak, right? We're saying the value that I want to modify is the value x, which is 10. And I am squaring it to get 100, or I am adding 20 to get 30. But notice that no matter what happens, I still get back my x after the fact, and it's still just 10. And that's because, again, x, we saw this before, is a literal and it can't be assigned. This is an integer and we can't reassign the value of an integer. So it's just going to stay that integer no matter what, and it's not going to modify the original value of x. And what you might be wondering, or why I'm phrasing it this way, is that, well, what happens if we do stuff with lists? And that's where things get a little more interesting. But first, before we go there, maybe what we need to do now is we need to say elif instruction is equal to, we'll say add 20 then we'll return value plus 20. And then we'll say else, and now we won't return something. Well, I guess what we'll do instead is we'll just say print error. Now, there's a lot better ways of handling errors that we'll learn about later, but for now, just know that this would be a good way to know that, okay, wait, now I got a printout message saying my new value is an error, and now I didn't get anything out. So there's a little printout to me letting me know that I did something wrong. So now I know that, okay, I need to specifically either say I want to add 20 and then I'll get my 30, or I need to specifically say that I want to square and I'll get the square. Otherwise, it will not work. Now, I can also just change this x to be 7, rerun this. Now I'm going to get 49 for the square. And if I get add 20, then I should get 27. Cool, so everything's working as expected. So awesome. You can have if-else logic. You can have as much logic as you want inside of a function. But notice that what happens, again, between the difference of returning a value and printing a value. All right, now what I also want to do is I want to show you this. So let's say if the value mod 2 is equal to 1, so in other words, if it's odd, I want to return the string odd, and then also I'm just going to write return even. All right, so I mean, this function doesn't really make any sense now, but now this function's returning odd, and if x is equal to 22, for instance, then this function is now returning even. Now, what I just want to kind of show you here is that notice that I don't need to even say if the value mod 2 is equal to 0, because in other words, you know, this is just kind of being smart with our programming here. Either it is odd or it is even. So if this statement isn't true, then I can just immediately return in the next line outside of that initial if statement, and I know that it must be an even number if I didn't get return odd. Now, the other thing that's pretty cool or clever about that is, if you remember, if this if block isn't or is true, then typically stuff will be ran afterwards in the code. So I could even say print I finished the if statement. All right, and so there we go. It says I finished the if statement and I printed even. And why did it print I finished the if statement? Well, it's because 22 is even. So was this true? No. So it didn't read into this indented line and it continued running the rest of the cells. But I want to show you something interesting and what happens when we run something if it's odd. If I now run this, notice that we don't get the printout of I finished the if statement. And there's a very cool reason for that, and that's because when Python reads the return function or gets to the return function anywhere in, return, I guess, key or name, so to speak, or like special, whatever, you get what I'm saying. If it hits a return statement inside of a function, then it will spit out the, right-hand side of that return statement, and it will completely exit out of the function entirely. In other words, it's kind of acting like a break or a break out of the function itself. So once it hits this return odd, it will not even get to the print afterwards, even though it didn't matter that this if statement was true or not, right? So in other words, usually what happens in if-else logic, like what we saw before, was that even if this was true and we said I want to print that it's odd, we would then say I finished the if statement anyways. And we would see that if this were just prints even. We can do that step and just show you the difference between printing and returning within functions. So now that these are print statements that won't act like breaks, all right, notice it says odd, I finished the if statement, and then it's going to print even anyways, right? So this is definitely not the behavior we want because it's saying odd and even all at the same time. If it was 22, then now it's at least just going to say even only because this statement wasn't true. But notice that that's some pretty nifty stuff that you can do there with the return statement. Is that, in other words, if you find the thing you're looking for, if you've done the calculation you need, or it'll show up in a lot of different ways in what you want out of your code, you can break out early and only get the value you want out without doing the rest of the logic. So a return will break out of a function immediately, which is a good thing to know. So that's some kind of advanced behavior of returns and handling some if-else logic. If you find a scenario that you're looking for, you can break out of your function early without needing to go through all the rest of the logic. Okay. So we did basic functions, function with the arguments, functions with return. Now it's time to look at functions that modify. So again, like I said before, is that x is just assigned to the literal integer, so we're not going to change much. And so now let's see what we can do with lists. So let's say I had an old list, and that list was equal to 5, 6, 7, 8, 9, 10. All right, great. So I've got an old list. And then what I can do is I can create a function called modify old list. Notice I don't need to even pass in an argument in this case, and I can say for x in old list, actually, let's see how I want to do this. I can say x plus equals 10, and let's just even stop there. Let's just see what happens. All right, so now what I want to do is I want to modify old list. I don't need to pass in an argument. That finished running. Let's print out my old list now. All right, so I didn't change anything about my old list, and that's because I was kind of just saying for x in the old list, x plus equals 10. And I was, in other words, just saying I want to know what that value was, and I want to add 10 to that value outside of the list. But let's see what I could do here. What I could do instead was I could say for x in range length old list, and we've seen that before, that now we're grabbing the index of each place in the list. And what I could do is I could say I want the old list at index x to have 10 added to it. All right, so now what I'm going to do is I'm going to modify the old list and then kind of just see what the old list is again. So notice now that 10 has been added to it, and I can run this again, and now 10's been added to it. I can run it again, and 10's been added to it. So in other words, my old list now has been modified by that function, and notice that there is no return statement or no input going into this. I'm calling a variable that I defined before my function existed, and I am able to modify that list as long as I'm doing some proper list logic inside of this function. Now that's some pretty impressive stuff, but it's more so a word of caution that when you've got mutable objects and you're trying to put them into your function, just be aware that you might be modifying the original function. Now, that's usually a behavior we don't like in Python. We kind of agree that you should always maintain the original input and only give a modified output. So let's see how we could do this instead. What we could do is we could provide an old list. And then what we could do is we could say, well, let's have a new list. And let's have that new list start off as completely empty. And now we can even say for x in old list, because we're not trying to re-index or grab values from the indexes of the old list, we just need the old list values. So I could say for x in old list, and then I could say x plus equals 10, and then I could say new list dot append. Well, actually here, let's cut that out and just put that right into the append statement. Okay. And then after that, I could return the new list. Oops. I guess they didn't like that. X plus equals 10. X.append. New list.append x. So I guess they don't like mathematical logic inside the append statement. Okay. So now I'm returning the new list. So I guess I should say my new list is equal to the output of modify my old list. Notice now I need to provide the old list. And there we go. Let's now check my new list. And now I get the 15, 16. So in other words, I had 10 added to every value of the old list. But here's the most important part. Now the old list is still intact. I have not modified it. Now this would be, again, more so what you would see in Python and just more so computing in general, is that, again, we don't like to modify the original input. We usually like to give a new output that didn't modify the old input. There are definitely reasons to go against that logic, and there are important times too, but for the most part, don't modify your inputs. Instead, provide a new output based on your input like we did here. Okay, so we show that you can modify things, whether it's an old list or a new list, and whether you're just creating a new list inside of the function and then returning it or not. Now, once again, what's super important here is, let's say that you run this function instead like this. Right, so I want to modify an old list. I modify the old list. Now what's my new list? Well, whoops, I got to restart the kernel. It's holding on to the last time I did it. Okay, so old list function, modify my old list. Now the question is, what is the new list? And unsurprisingly, again, it's going to say new list is not defined, because again, we can't actually grab hold of that new list unless we return it and store it in a variable. Now, one other thing, just to say out loud, hopefully it makes sense, is that you don't need to name your new variable that you're returning it to the same as what it is inside the function. So I can still just call this y, and I can still get y, and that still works. Even though y isn't the same name as new list, it's still behaving in the same way. Whoops. There we go. Okay, awesome. All right, there's one last thing to do, functions that iterate. Now, we kind of did that because we had for x in old list, but yeah, you can have a function that iterates through things. So we could say def make string crazy, and then we could provide we could just say input string. And then we could say for character in input string, and let's even do this. Let's just say new string. Now, we wouldn't need to provide new string, because remember that strings can't actually be modified, but we're instead going to create a new string. So we could say for character in new string, we could then say new string plus equals the character, and then also plus 4 A's. And then of course we can return the new string. All right, so we could then say long string is equal to make string crazy, and then we could say Python is great, just like we started off with long ago. And now let's look at the long string. All right, and so now we've got a bunch of A's happening after our input string. So one thing we could also do to make this more fun, all right, we could say for character and range length input string, we could say the new string is equal to, let's do this, the input string at the given character. And then this will be fun. You might not have seen this behavior before, but you can take a single character and you can multiply it by, and that will repeat it a certain amount of times. And what I'm going to multiply it by is the index. So now the amount of A's are going to get longer the longer my string is. So there's 0 A's at first because I was at the 0 index, 1 A for the Y, 2 A's, 3 A's, and it just gets worse and worse and worse the longer it goes. So we are iterating through every character of that string and then doing some behavior inside of a function. So cool. That's all the basics you need to know about functions. Hopefully now you understand the difference between simply printing something in a function and returning it, understanding that the return will break out of a function early, no matter where you are in if, else logic or anything else. Noticing that functions can take one or two or many or zero inputs, but you just need to make sure you match the amount of inputs required based on the amount of inputs in the definition, required inputs. Notice that you can modify mutable objects in a function whether you return it or not, depending on how you do your logic, or in good Python practice, you can take in a mutable object and then find a way to modify it while still keeping the original intact. And last but not least, we can, of course, iterate, which we already did inside of the list, or even inside of an immutable object like a string, you can still iterate through it in a function and create some sort of new wild string. So there's a lot to unpack with functions, and hopefully that was a good kind of first course. And finally, we're ready to do some really cool stuff in the next video. We're going to compare function performance and start really kind of getting into a computer science concept called, big O notation and understanding time complexity. So that's going to be a big one. And it's going to be really important in your Python journey as you start forming functions and thinking about how to program and create things that will run quickly, efficiently, and do the task that you need done in the best way, which varies on a case-by-case basis. All right, so see you in the next video.